This lesson is for day 3 of section 1, Geometry Basics. So we're going to start out by talking about a midpoint. So we talked about things that bisect, right? And bisect means to cut exactly into two equal or congruent pieces. So the midpoint is what bisects a segment. It is the point halfway between the endpoints of a segment. So if I wanted to know what value was the midpoint of AD, A is at negative 12 and D is at 18. So I know overall this segment would be 30 units long, right? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So half of 30 is 15, but it'd be crazy to say the value of the midpoint is 15, right? Because that's way too close to D. So what it is it's 15 away from A and it's 15 away from D. So if we did 3, 6, 9, 12, 15, and we checked it the same way, 3, 6, 9, 12, 15, that means the midpoint of AD is 3. Another way I can get to the value of 3, knowing the endpoints represented negative 12 and 18, is if I took negative 12 plus 18 and divided it by 2, right? Because that becomes 6 over 2, which is 3. So what we're really looking at here is the average. When you take two things together and find their sum and then divide it by 2, or take three things and divide it by 3, that is the average. So we're finding the average of the two endpoints to find the value of the midpoint. The same can be said if it has more than one dimension here, right? This is just a horizontal line, but if I had a diagonal line that has an x and a y component to it, I have to account for both. So that's where we get the midpoint formula. If you have two different points, A and B, and A is represented by x sub 1, y sub 1, B is represented by x sub 2, y sub 2, then the midpoint for that segment is going to be the sum of the x's divided by 2, or the average of the x's, comma, the sum of the y's divided by 2, or the average of the y's. So for our first example, we want to find the midpoint of PQ. I'm going to label x1 and y1, or x sub 1, y sub 1, x sub 2, y sub 2. I'm going to substitute them into my formula. So we know the midpoint formula is x sub 1 plus x sub 2, 7 plus 3 over 2, comma, y sub 1 plus y sub 2, so that's negative 2 plus 8 over 2. So now I'm going to simplify. 7 plus 3 is really 10 over 2. Negative 2 plus 8 is really 6 over 2. So that means my midpoint is 5, comma, 3. I'm always going to write the midpoint as an ordered pair inside parentheses because it does represent a point in the coordinate plane. So you can try the next one. You can pause it and I'm going to put the answer. All right, so you could either have written it as 7 halves and 19 halves or 3.5 and 9.5, right? Doesn't matter which way we write it, whatever you're more comfortable with. In our next example, the midpoint of RP is M2, 4. So we're told the midpoint. We're also told that R, one of the endpoints, is negative 1, 7. We want to find the coordinates of P, the other endpoint. So we're looking at M being in the middle at 2, 4. Now, even though I'm drawing it horizontally, that doesn't mean this represents a horizontal line. Right? R is over here at negative 1, 7. And P is at the other end, and we don't know what it is. So we can do this algebraically, we can make equations, but there's actually a simpler way of doing this. We know m is exactly in the middle of these two. So whatever distance it takes to get from this point to this point, it should be equivalent to get from the midpoint to the other endpoint. So what I'm going to do is I'm going to look at the x's. What did I have to do to get from -1 to 2? So if I add 3 to -1, I get to 2. So what I need to do is I need to now, again, add 3. So 2 plus 3 is 5. And now we're going to do the same thing for the y's. From 7 to 4, I subtracted 3. So now from 4, I will subtract 3. So 4 minus 3 is 1. So that tells us that the ordered pair for P is 5, 1. So you can go ahead and try the next one, pause it, I'm going to show the answer. All right, so we should get 9, -7. This next example is actually much trickier than anything you would have to do on your own, but it is still something I want to show you. So for this example, point P is located on a segment between point A and point D. So we know A and D are at the ends. A is 1, 4, and D is 7, 13. P is somewhere in between here. The distance from A to P is twice the distance from P to D. So it's 2 times as long to get from A to P as it is from P to D. So what that tells me is if this distance is x, this is double that, or 2x. Or if this distance was y, this is double that, or 2y. So now I'm going to look at the actual endpoints. I started at an x of 1, and I ended at an x of 7. So total distance traveled on the x-axis is 6. So my x distance is 6. And I know that that 6 is really made up of 2x and x. So 2x plus x equals 6. All right, or 3x equals 6, and x is 2. So if x is 2, 2x is 4, which means 4 away from the 1, or 2 back from the 7, is my x value for P. So if I do 1 plus 4, I get 5. Now, for the y's. If I look at my y value, 4 to 13, the distance that travels for y is 9, right? 13 minus 4 is 9. So now we're going to do 2y plus y equals 9. Or 3y equals 9. And y is 3. So if y is 3, 2y is 6, which means either 6 up from the 4 or 3 down from the 13. So 4 plus 6 is 10. So that makes point P 5, 10. All right, moving on. For example 4, point M is the midpoint of VW. We want to find the length of VM. So by telling us that M is the midpoint, we know that VM and MW are congruent. And since I have values for both of them, I can set them equal to each other. So 4x minus 1 is going to equal 3x plus 3. So subtract and add. I'm going to do both steps at once. Minus 3x is x, plus 1 is 4. So that's the value of x, but that's not just what they asked us for. We want to find Vm. So I'm going to take the value of Vm, 4x minus 1, and I'm going to plug 4 in for the x. So that's 16 minus 1. Vm equals 15. All right, you're going to try this one, pause it, and then I'm going to show your answer. All right, should have gotten x is 2 and mq is 7. The next thing we're going to talk about is distance. So distance is also the length of a segment, or when we talk about distance, we're actually talking about the distance between two endpoints. All right, so distance and length are going to be interchangeable when we talk about segments. So we have something called the distance formula. So if I am again given two ordered pairs, x sub 1, y sub 1, and x sub 2, y sub 2, then we have the distance formula here, the distance between A and B, or the length of AB, x sub 2 minus x sub 1 quantity squared, plus the y sub 2 minus the y sub 1 squared, and that entire thing under the square root. The square root should be the very last thing we're doing. We're subtracting first, squaring, and then adding them together. So in this example, we want to find the length of each of these segments. So AC, and if I look at my picture, AC is actually a vertical line. Vertical lines are great because I don't actually have to use the distance formula. If I have a coordinate plane, I could just count my boxes. Or if I notice that I have two x values that are the same, that's what tells me it's a vertical line, I could find the difference of the y values, right? I'm going from 8 to negative 4. But since we have the box, we can count. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that distance is 12. Right? Or 8 minus negative 4 was 12. BC is also good. It's a horizontal line for us. Right? We notice they both have the same y values. So we're really checking how am I getting from negative 5 to 3. So if I did negative 5 minus 3, I get negative 8. But we know it always has to be positive. So I'm going to say that's positive 8. Now, for my last one, I actually have to use the distance formula, right? This is a diagonal line. I cannot count boxes for a diagonal line. So I'm going to do the distance formula. My 2 points are negative 5, 8, and 3, negative 4. I'm going to label x sub 1, y sub 1, x sub 2, y sub 2. And I'm going to plug them now into the distance formula. So that's going to be x sub 2 minus x sub 1 plus, all right, that was squared, plus y sub 2 minus y sub 1 squared, and the whole thing is under the square root. So we said we're going to do what's inside the parentheses first. So 3 minus negative 5 is really 8. So it's going to be 8 squared plus negative 4 minus 8 is negative 12 squared. So 8 squared is 64. And this next part's the part that always trips some people up. If you type negative 12 squared into your calculator without parentheses, it might think you mean negative times 12 squared. If you think about it, if you're doing a negative 12 times a negative 12, the negatives are going to cancel. It's going to become positive. So no matter what, we should always end up with a positive number down here. So that's 144, right? 12 squared is 144. So together, that's 208. which means I'm going to write AB equals, and if I put the square root of 208 into my calculator, some people's calculators might give them this. That's an exact answer, right? There's nothing to be rounded. Square root of 13 is an irrational number, so it would just stay like that. Or some people's calculators might give them a decimal, and we're going to round, I'm going to say right now, to the 100th. All right, that's an approximate answer. Later on in the year, there will be times that call specifically for an exact answer, and there will be times that call for an approximate answer. So you're going to go ahead and try this. You're going to find AC, pause it, and I'm going to show the answer. All right, so is the square root of 17 or 4.12? The last thing we're going to talk about is finding perimeter and or area of figures on the coordinate plane using the distance formula. So we want to find the perimeter and area of triangle ABC, and it gives us the vertices A, B, and C here. Just a quick note, we do notice that B and C both have the same y value, so I know I will at least have one horizontal line in my picture, which means I don't have to do the distance formula for that side. I am going to quickly draw a rough sketch, right? Doesn't have to be perfect. I have 1, 3 is A, 4, -3 is B, and -4, -3 is C. So we're looking at a picture that looks something like this. I know that, like I said before, I can count to get from here to here. I'm going from the -4 here to the +4 here, and if I count it all the way over, I get 8. So BC is 8. But I don't know AC or AB, so I'm going to have to do the distance formula for both of those. So for AB, we're going to do 4 minus 1 squared plus -3 minus 3 squared. So that's 3 squared and -6 squared. And remember, the negative doesn't really matter. It's going to turn positive when we square it. So that's 9 plus 36, or 45. And that turns into 6.71 about. So I'm going to put 6.71 over here. And now we have to find AC, right? If I'm looking for the perimeter, I need every side. So for AC, we're using A and C, so -4 minus 1 squared plus -3 minus 3 squared so that's going to be -5 squared and -6 squared. So 25 plus 36 is 61. So we're looking at the square root of 61, which is about 7.81. So my perimeter is going to be adding all three of those numbers together. So 8 plus 6.71 plus 7.81 is 22.52. And they didn't give us any kind of units for this. Area, if you recall, area of a triangle is 1/2 times base times height. I already have a base. My base is 8. So now I need a height. And if I look at this A and I kind of draw my vertical line from A, I'm going up from +3 all the way down to -3. So that's a distance of 6. So my height is actually 6. So my area, if I'm going to do 1/2 times the base of 8 times the height of 6, that is going to give me 24 square units of whatever they were. You can go ahead and try this one. I'll pause and show the answer. All right, so your perimeter was 13.83, your area was 7.5. The last one for this section, you're building a shed in your backyard. The diagram shows the 4 vertices of the shed. Each unit in the coordinate plane represents 1 foot. Find the area of the floor of the shed. So since these are all vertical and horizontal lines, that's good for us. We get to just count. So 1, 2, 3, 4, 5, 6. Horizontally, the distance is 6. 1, 2, 3, 4, 5. Vertically, the distance is 5. So the area of a rectangle is length times width. So that is 5 times 6. And that is an area of 30. And since they told us each one was 1 foot, right there, feet squared, right? Area is always a squared unit. And that is it for day 3.